Right. Okay. The magic show. For this show, I need a coin. Does anyone have a coin?
How big?
This is fine. This is fine. You don't have any kind of sentimental value attached?
No.
No. Are you sure?
Yeah, just a 1 rupee value.
Because I'm going to make this disappear.
No problem.
You sure?
Yeah.
Okay, all right. Good. What I think you haven't been told about me, there's something I have actually hidden about me from you. And that is that I am a magician. Surprised? Yeah? So how many of you actually think that I could be a magician? Thumbs up if you actually think, if you believe that I could also be a magician. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, okay, most of you. Normally when I ask that question, hardly anyone believes me. I'm actually touched that you all think and believe that I could be a magician. That you actually trust that I could perform some magic trick. And that's actually what I'm going to do, perform a magic trick. I am going to make this coin disappear and hope that he doesn't cry. Right? So you still think that I'd be able to do that? All of you, most of you, still believe that I'll be able to make this coin disappear? Yeah? Yeah? Then why do it then? Why do it? I mean, if you believe that I can do it, should I go ahead and do it? Should I? Do I need to prove to you? Really? I have to. Oh, so you want me to actually prove to you that I am indeed a scientist? What's the point? I mean, you believe anyway. Why would I need to prove myself? I mean, if you believe in a politician as being honest, why would a politician need to prove that he's honest? Right? Or is that not really right? As scientists, what do you expect? And proof for anything that you contend, right? All right, so I guess I do need to prove to you that I can indeed make this coin disappear. Watch carefully. Nothing here, okay? Here it is. Ta-da! Why are you laughing? Where's the coin? What? Where? Which pocket? Oh, right, it is here. I think I need to practice that trick. I guess it's too early to perform that trick. I think that's the lesson I've learned. I need to do it. I need to practice, get better at it, and then only maybe perform. That's the lesson that I'm going to take from here. But you know, there is another way that I can make this disappear. I do have something else up my sleeve, as it were. Up my sleeves. You know that when they say that, right? Magicians have things up their sleeves. I do have a second trick. But for that, I need you to close your eyes. Why are you laughing? Why are you laughing? I just want you to close your eyes and I will make this coin disappear. Right. Can you all close your eyes, please? Close your eyes, everyone. Close your eyes. All eyes closed, please. All eyes closed. All eyes closed, please. All right. Do you see the coin? No. See? I made it disappear. No, don't open your eyes. You can't open your eyes. Do you see it now? No. See, I made it disappear. Didn't I? So I am indeed a magician. Or did it disappear? Why aren't you convinced that it disappeared? Why do you say no?
Because I trust myself and my eyes were closed. You told us to close our eyes.
Okay. So if you didn't close your eyes, the coin wouldn't disappear. Really? Okay. Don't close your eyes. Put your hands like this, fingers like this. Put it in. Here's the coin. Here's the coin. Keep your eyes open. Put. Go on. Go on. Your eyes are open. Your eyes are open, right? Where's the coin?
It's still there.
No, it's disappeared, hasn't it? Your eyes are open. The coin still disappeared. Coin's not there anymore. You can't see. See, I told you I had things up my sleeves. I had tricks up my sleeves. Well, what happened? Was it magic?
No.
All right, so what happened? What happened? Why were you not able to see the coin? Why did the coin appear to have disappeared? Okay, tell me more.
Imagination.
No, because we kept something between that coin and our eyes and blocked it like this. That's why we couldn't see.
Oh, so because you put something in front of your eyes, you couldn't see it. Okay.
The light from the coin to reach our eyes.
All right, here is a scientist now. Are you a scientist? Are you a science teacher?
Yeah, I was a scientist.
Okay.
I was a scientist.
All right, go ahead.
Yeah, so to see any object, the light reflected by the objects to reach to the retina of the eyes, and the brain interprets, and that's how you know that the coin is visible.
Uh-huh. And when you had your eyes closed or when you had your hand in front of your eyes, what happened? All right, you blocked the light, the reflected light coming off of the coin from reaching your eyes and then forming an image at the back which your brain interpreted. So as long as you have eyes and a brain, and as long as light is coming off of objects, or as long as an object is giving off light, you should be able to see the things. Right? That's the conclusion that I have come to now. Right? Have you seen blind people with eyes? Yeah, they have eyes. Why don't they see then? If all that's necessary is for there to be eyes and brain and an object that gives off light or light reflects off of it, reaching their eyes and so on, why are blind people with eyes not able to see? Okay. There may be a defect in their eyeball or retina or in the brain, right? Okay, so now let's establish what it means to see. What does it mean to see? So what does it mean? Come on, someone raise their hand and summarize what it means to see. Anything. To see anything. What does it mean? When you say, I see something, what does that mean? Yeah, in terms of what we just discussed. Yeah, it's scientifically, of course.
When my brain can understand the optics.
Okay, you're going a little too far. So we established that light has to either be reflected off or emanate, produced. The object must produce light and reach the eyes, which must be functioning. It must be functioning. And then the image forms at the retina and the brain also, right? must also be able to interpret that image. Right? So those three things must happen. Those three things must be happening whenever you see something. Light from the object, eyes functioning for an image to be formed at the back, and the brain must be capable of interpreting that image. All right. Maybe it will work. Let's see. How many of you see that coin? Who can see that coin? No? Light is reflected off of the coin. Your eyes are all functioning. Your brain is still functioning. Why is it that you can't see the coin? I'm now really surprised. That's not even a magic trick. But why aren't you able to see the coin?
Because in a certain medium, light always travels.
Hold on. That's not the answer.
Not the light.
You're just giving me a theory. You're just giving me a statement that's true.
The light ray coming from the coin, reflected by the coin, cannot reach our eyes.
Cannot is not, or?
Is not reaching.
Is not reaching. Okay.
Is not
Why?
reaching the eye because light always travels in a straight line.
Okay. I am pretty certain that light from this coin are all traveling in straight lines. I am pretty certain. I am dead certain just putting that on the bowl has not changed the fact that light travels in a straight line. I don't think that's the answer. Now, I am becoming very, very specific, and this is science. You have to be very specific. Right? That's not quite true. Why is it that you're not able to see?
Because the light that's coming out from that coin is blocked by the walls of that.
What about the light that comes off the mouth of the bowl? It's not blocked. Okay, the ones that would make it to your eyes are blocked by the side of the bowl. And those that are traveling out of the bowl, they're going somewhere else. They are not arriving in your eyes. So it's true, light travels in a straight line, but that doesn't explain that doesn't answer my question. Does that make sense? All right. Okay. So, just like when you put your hand in front of your eyes, right? The reason you don't see the coin now is not because there's no light coming, your eyes, something's happened to your eyes, or something's happened to your brain, but because the light, that which would otherwise reach your eyes, are not reaching your eyes, because they're being blocked by the bowl. Right? Okay. अर्को पानी छैन? Is this is not, I don't want to use drinking water. Tap water भए पनि हुन्थ्यो. All right, so going back to what he was saying. Light travels in a straight line, and that which would have traveled in the line which would have reached your eyes aren't reaching, and therefore you're not seeing. All right, here's a magic trick. Maybe not all of you might see it, but do you see it? Do you see it? Yeah? Okay, you can see. But I thought light traveled in straight line.
But maybe the light is bending.
The same medium only. Light travels in a straight line in a medium, but when it travels from one medium to other medium, it bends.
Okay, now tell me how it is that you're able to see that coin now.
The light without keeping water, which would go upward, would not reach our eyes, is bending and coming to my eyes.
Okay.
And that's why I'm being able
So I'm not a science teacher, so I'm not understanding. So it's not true then that light travels in a straight line.
It's true, rectilinear propagation of light holds only for a medium.
Ah, okay. All right, now we're going to revise now. Light travels in a straight line in a medium.
But when it travels from one medium to other medium, it bends.
Oh, okay. And we can talk about why it bends and so on, but that's something. Okay, so water is one medium. Air is a different medium. Now, explain to me, once again, for the benefit of people who are not scientists, how it is that you now are able to see the coin, how it is that this does not constitute magic.
Because the light rays coming from the coin is traveling from water to air, and then that's the reason why it's bending.
Okay, so when it travels up, reaches the surface, it bends and
It comes
to an angle, and it arrives to your eyes,
Yes.
and you're able to see the coin. Are you seeing the coin really?
Yeah.
Okay. All right. So sometimes what happens is you can see things that aren't necessarily in direct line of vision because of this particular property of water and air and other medium where light bends when moving from one to the other. Right? All right. Yeah. Are you sure you're seeing the coin?
Yeah, I'm sure.
Are you sure you're seeing the coin?
I'm seeing the apparent position of the coin, not the.
What does that mean, apparent position? Oh, you can't. That's fine, but they can. What does that mean, the apparent position of the coin?
Actually, the light from without water, light goes straight, but it is bending. But I see the coin in the line of the light ray that is coming to my eye.
So you still see coin then?
Yeah.
Really? Really? What was that? Right. Okay, go on. Go on. What are you saying? So that everyone hears. What are you seeing?
Actually, you have put an object there. It's a coin, and because of the reflection, we can see the image of the object.
You don't see the coin. You are seeing the image of the coin. That's very important. Very important. Remember that. As a matter of fact, what I see here is not you. What I see here is the image of you that forms at the back of my head. And as a matter of fact, the image is actually upside down. My brain flips it up. So really, what you see is not the coin. You see the image of the coin. That's important to remember, okay? And this, of course, with students, this can be very, very interesting, right? Very interesting. And we'll talk about that later too. I'll come back to that later. All right, so light travels in a straight line. It bends when it travels from one medium to another. It may bend, and as scientists, as physicists, we will talk about the fact that it bends towards the normal or away from the normal and so on and so forth. You know, we can do that. And so sometimes you can see objects that are not in direct line of sight. All right, fair enough. And let me reestablish what it means to see. What does it mean to see? This is again a quick review now. What does it mean to see? What does it mean to see? Three things again. What does it mean? When someone says, I see you, what do they mean?
First, the object should reflect the light.
So reflected light or light from the object,
Yeah, and then it should reach to the retina.
right?
And the image is formed, and the image should be understood by the brain.
The brain does not understand it, but the brain interprets it. Yeah. The most obvious thing that the brain always does is to flip the image. Okay, that's something that it does automatically. All right? All right, fair enough. Okay. So as long as there's light coming off from the object, and as long as it reaches your eyes, I think I have another coin. I've got one here. You should be able to see, right? Right. That you're able to see this now, and you weren't before, was pretty straightforward, right? I told you I have lots of things up my sleeves. Let me get a white piece of paper because the coin and... Now, for this, I may have you all, maybe not all, but just stand around here. Just make a big circle. You can stand where you are. Just a big circle, yeah. Just around, go, big circle. Right, okay. So, do you all see the coin? Yeah. And notice there's an object on top of it, obviously, the beaker, and yet you see the coin, right? The scientists that are here will be able to explain, right, what happens to the light that's being reflected and so on. There's some refraction going on and so on, right? There are a couple of medium changes and so on, but still light is coming to your eyes and you're able to see. What if I told you I'll make it disappear without even touching it? Why didn't you stand over there? What if I told you I will make that disappear without even touching it? Anyone?
I'm going to clap.
Are you just going to clap? How many of you believe me?
Again, you tell us to close our eyes.
But that's an old trick. I did that already. I'm not going to do the same trick again and again.
Are you going to pour some water in there?
I don't know, but do you believe me?
Yeah, I do.
Yeah? What? All right, okay. Watch. Watch. When it disappears, say, it's disappeared for me. It might not happen to all of you at the same time, but why don't you walk just a little bit closer? Yeah, you too. I just need different people at slightly different distances. Okay. All right. Tell me when it disappears for you. Disappeared. See, I told you. All right, for some it's disappeared. Disappeared. See? Magic. Disappear भएको छैन है? यता disappear भइसक्यो. So, where is the clapping? Where is the applause? अरूलाई? Disappeared. Yeah? Magic? Yes. Oh, come on. I taught you. It's science. And what is science, really? It's magic. And magic is science. And that is something I think we don't actually impart to the kids. There's so much magic in science. Not just magic, but also the things we can do, the little things we can do, you know, to get them excited. But as a scientist, you can explain magic. What happened? What happened? What happened here? Remember the three things. What happened? Your eyes haven't all of a sudden stopped functioning. Your brain hasn't stopped functioning, but how do you explain that? How do you explain that?
I think, again, another medium has come between. So we just understood that, you know, when the medium is different, light, the rays of light bends. That's what
Yeah, that's a true statement, but you haven't explained why you can't see.
that will happen when you get see.
No, light is still being, I can guarantee you that light being reflected off of that coin is all coming out.
But not, it is not coming to our eyes.
That's it. All right, so in a complete sentence, please. Why is it that you are not able to see the coin?
The light rays coming from the coin is not reaching our eyes.
Uh-huh. Now, why isn't it reaching your eyes? Could be a little more interesting, right? And if we had time, we could go into that after you teach your kids about refraction, reflection, and so on, right? All of that. And you could even have your kids make a diagram showing what potentially might be happening with ray diagram, right? Okay. Now, whose coin was this? Mine. I'm sorry, right? But you know, I will double it. Would that make you happy?
Yeah, if I can take it.
That I cannot promise you, but I can double it. As a matter of fact, you might already see 2, maybe not. You might have to walk a little bit closer. Do you see 2 now?
I can see actually from here.
Just walk a little bit closer and you should be able to see 2 coins.
I can see it.
Do you see 2?
Yes.
I can see too.
Do you see 2? See? 2. 2 coins. He's rich. I've made him rich. So why are there 2 now? That, of course, is a little involved, but the concept involved is, science teachers, what makes an image on the other side appear? What makes the image on the other side appear? What is the reason for an image appearing on the other side, the far side of the beaker? What is that light thing? No. Total internal reflection. Thank you very much. That's why, right? And now you should be able to realize what you see is an image, not an object. Right? Because the coin is not on the far side of the beaker. You know that. But it appears on the far side. All right. So now I hope you realize that when we talk about what we are seeing, really we're seeing the image. All right? Not the object itself. Sure, there are times when the object and the image is the same thing, one and the same thing. But there are times when the object and the image are quite different. And this, I hope, dramatically shows that. Okay, take your seats. Okay, let's go back and once again establish what we know about what seeing means. So what does it mean to see now? Once again, what does it mean when you are seeing something? 3 things. The conditions necessary.
From the object reach to our eyes.
Uh-huh.
The image forms.
Yeah, the eyes function and image forms at the back. Okay. So as long as light from things out there arrive at our eyes, and our eyes are functioning, and our brain is able to interpret the image at the back, we see what is out there. And sometimes we see the image. Is that a fair enough statement? And is that always the case? Is that always the case? Do we only see that which is out there? What do you mean?
Because I saw a double coin, that means sometimes you see the object and the image.
Right. So sometimes what you see is not really what is out there. And why does that happen? Why does that happen? You've seen an example here. Why does that happen? Huh? Anyone? Just with this example.
Light bends when it travels from one medium to the other.
Okay, but because of that, does it always?
Yeah, so when it becomes extreme bending, you go to total reflection.
Okay. Yeah. So when there's lots of refraction, reflection happening, right? It may produce a situation where you see something that is not there, right? Really. And it's just an image. I'm sure in real life you've seen that. Or maybe you've heard about that. Where does that happen?
In desert.
In desert, yes. Go ahead, describe for everyone else.
Generally, what happens, we carry water, but that water sometimes it's not enough for us. So what happens, sometimes we look for water, and then we see the image of water and the trees, the date trees and all. So that's the way oasis here.
Right. What you see in desert, what we call oasis, is another example of that which, yeah, right? Again, that is a result of what's happening to the light rays out there. And highways, yes. If it's a hot day, yes. You see puddles of water. Yeah. All because of the extent to which refraction takes place and so on. Is that the only time when you get tricked? Is it? Is that the only time when your sense of sight gets tricked? You're shaking your head. Is that it? Is that the only time? Really? Okay, all right. Oh, where is it? Sometimes it's what you believe that you see. What do you see? All right, a girl. A girl. Who else sees a girl? Thumbs up. Okay. Pretty much everyone. Is there anyone here who sees something else? There's no waterfall. Nope. A wall? Nope. Nope. Yes? An old woman. Anyone else see an old woman? Okay, here's a thumbs up. Just 2, 3. All right, those of you who see a young girl, try to see the old woman. You see it? Okay. Do you see old woman? All right. So the young girl, everyone sees, right? How many of you here don't see the young girl? Thumbs up. Okay, all right. The young girl is facing into the wall. This is her nose, that's her eyelid. Okay? Does that make sense? Now, the old lady. Someone want to describe the old lady? Describe the old lady. So the young girl, we're seeing the back of her face. The old lady, what do we see? Side view, profile. You see the profile of the old lady. Do you see that? What is the chin to the young girl is the nose for the old woman. So how is it? The rays coming from there for every single one of you was the same, but some of you were not able to see the girl or the woman. How and why? Think about it. And here's another one. Think about the question. What's it doing? What does it appear to be doing? So what if I told you that the T-Rex actually does not follow you, or is not actually following the camera? It's not. But what does it appear to be doing? It appears to be following you. But it's actually is not following you. So what's going on? Remember, to see, light, eyes, brains, right? And it's related to also the other image. Why some saw the young lady and not the old lady, and others saw the old lady but not the young lady.
Because every angle, from different angle you're looking at it.
No, it's got nothing to do with the angle. The rays coming off of the images for every single one of you is the same. The image at the back of your head, are they the same? Then how is it that some saw the old lady and others saw the young lady?
Maybe it depends how our brain interprets it.
Go on. Thank you very much. All right. Go on. Go on.
The light rays come and our eyes do not see it. It must be interpreted by our brains, and different people's brain might interpret it differently. And so how the light reaches and how we interpret it first, and we keep on seeing this.
Okay. So it's not always true that what's out there is what you see. What is also the case is what we want to see is what we see. Right? What our brain wants to see. For whatever reason. With that one, who knows, right? For some reason, some of you saw the woman and just couldn't see the girl. For whatever reason. And with this too, I'll show the whole thing. Our brain refuses to accept something and forces us to see something that's not there. In other words, our brain takes over. Right? So seeing now is, again, light, eyes, the brain. Okay? Every single one of these plays a role. Okay. To now reveal. What do you notice? It's not 3D. Our brain refuses to accept that the image actually goes in. The nose, all of that is actually inside. So the brain refuses to accept that it's not 3D. So it actually makes up. It adds what the brain thinks is missing and sees this 3D head moving. Okay? All right. Fair enough. Let me see what time it is. Okay. So the act of seeing now is light, eyes, brain. A lot of times we see that which is out there. Other times we actually just see the image of what is out there. And also, there are times when we see that which is not out there because our brain refuses to accept that and so makes up for what it thinks is missing. Right? So, while we say that seeing is believing, there's also some believing and seeing going on, right? A lot of times. And this is science. And of course, this is all related to physics. And you can do a lot of this with your kids, right? To actually get excited about just a simple lesson, a simple topic, reflection and refraction, and light, right? So this is another way of teaching that. There is more to this. I'm just wondering, for time's sake, there are more other... One of the things I try to do with the students is, while teaching these simple things about refraction and reflection, I also bring in these interesting tidbits. Because then kids get really, really awed, right? When they learn new things, they get awed, right? Like, for example, adding to this now. So if you look out the window, what you see, pretty much you can be confident that they're out there, right? Why? What you see out there is out there. Why? Why would you be pretty confident, very confident, that when you look out the window, what you see out there is indeed what is out there? Why would you be confident in that? Because you believe, and what else?
Because we've been there.
Because you've been there, you've walked, and so on. Sure, the light rays are coming through the window sill, right? There may be some refraction and so on, and therefore what you see might be the image, but in this case, you are confident that the image is the object itself, because you've been there, you've seen it, you know. Can you always be certain that what you see out there, what you think is out there, is out there? When would you not be confident? Is there a time when you would not be confident that what you see is actually out there? Is there a time when you would not be confident? Yes?
When it's dark.
When it's dark. Go on.
Like when it's dark, when you walk for the first time, let's say in your own room also, and the light, it looks something else, so the object looks something else. Like, let's say a person is standing behind a curtain or something, but because of the lack of light, it looks like that, but it's not there, but we are not confident that.
Okay, so when you are tricked because of the kind of lighting and so on, combination of lighting, I'm thinking of something more than that, where we see things that actually every one of us have seen, things that don't exist. There are. And I'm not talking about ghosts. No. When you go out at night and you look up into the sky, what do you see? If you're lucky. Kathmandu. If you go to the mountains, look up into the sky, what do you see? You see stars, you see planets, you see satellites. If you're lucky, what? Oh, right. You'll see, yes, the Milky Galaxy, right? You'll see constellations, shooting stars. Are they all there? Is everything that you see, all of that which you see at night in the sky, are they all there? First of all, are they all where they appear to be? And are they actually there?
Maybe not.
What do you mean? What do you mean?
Now, my understanding is light also takes time to come to our Earth, and some of the stars are million light year away, and the light wave which came million years ago is just now coming to our Earth, and they might be dead, might be supernova already happened there, explosive star might have been exploded, and the stars might not be there what we are seeing.
Right. Because it's taken so long for the rays to arrive here. By the time it arrived here, by the time you're seeing it, it's gone. So it's not true that what you see is always there. Are all of that which you see up there, are they where they appear to be? To all of that which you see up there, if you were to shoot a rocket straight to it, will it reach? In every case, will the rocket reach the... Why not? Why not? I might be a magician, but I can't tell. Right?
Because what you're seeing is not an object, it's an image.
Okay. What do you mean?
It's actually not it's not the exact position that you have, because of the refractions and because lots of light is lost in the middle of the way.
Okay, there is that. But we've moved beyond the refraction and so on. Okay? We've moved beyond that. What do you know about space out there? It's nothing, okay. All right, let me give you a hint. We talked about how light travels, the fact that it travels. Okay, all right. The earth is moving. Is it always true that light travels in a straight line?
Even the strong gravitational force bends it.
Thank you very much. So, what? Now, going back to the original question. Are all of the celestial objects that you see up there, are they where they appear to be? Okay, go on. Why not?
The light rays coming from the stars are bent by probably the gravitational force of the sun.
Is it the sun? The sun, not really the sun. Not the sun. There's other things.
There are also no supermassive black holes in our galaxies.
That's it. Thank you. So some of those celestial objects are not where they appear to be because their light may have been bent by a black hole and they appear to be here. Whereas they're here and the rays come down like this and then they appear to be here. So it's not always true that light travels in a straight line. Okay? Now that can be mind-blowing to a little kid. Right? Okay. Yes?
When a light enters the black hole, it just gets captured. It cannot come out.
Right. Not all light get captured. Some are just beyond the periphery of influence. Right? Thank you. I'm not a physicist, so those that which are outside the event horizon don't get captured, don't fall in, but are still influenced enough to bend. Okay? Does that make sense? How crazy, right? So, can you always believe what you see? No, but that is not to say don't. Okay? All right. Yes, because sometimes your brain wants not to see it. Like problems happening in your homes, right? Problems in your society, right? Issues our society faces, right? Because sometimes you just want to be able to function, right? So, anyway, all right. Thank you very much for being a good audience to my magic show. That's the end of the show. Anyway, this is an example of discovery learning.